All right, my darlings, let's go through this so that you can ace this test, which is a hands-on lab, in 3 parts for honors, 2 parts plus a bonus if you choose for CP. First 2 parts are about circuit and series. You need to create a circuit with a battery, light bulb, and a switch, all connected in series. So if I were to draw that, something like that. Here's your battery, switch closed in my diagram, and a light bulb. Real life. Here's your battery, switch, light bulb. It is on because the switch is closed. If I open the switch, then the current will stop. If we were to show the direction of the current, it would be from positive terminal because we pretend that it's the positive charges, although we know it's electrons, but such is the conventional current. Then what do we want to add? We need to measure voltage across the light bulb and the current in the circuit. So we need to connect a voltmeter and an ammeter. I'm using a voltmeter to measure the voltage only for the light bulb. Remember, in real life, wires do have resistance, and also batteries have internal resistance. So theoretically, if I measured the voltage on the battery, it should be equal to the voltage of the light bulb, but it's not, because we know real wires do have resistance. So that is why I specifically ask you to connect voltmeter to the light bulb. So you put it in parallel, right, on either side of the light bulb. However, ammeter needs to be connected in series in order for the current to flow through it. So the reason for voltmeter being connected like this, voltmeter has a huge resistance and very little current flows through a voltmeter. So our current goes like this, splits a little bit of it goes into a voltmeter, practically nothing, and then unhindered this current goes through, and then ammeter has to grab all of it in order for it to tell us the real story about the current that is going in the circuit. So what should we notice? We have our red prong in the volts, commas in the middle as per usual. Here's where our dial will be in the direct current, around 20, and then that reads 3.07, and since this is my data, I'm going to go ahead and write 3.07 volts. That is my voltage on the light bulb. Then I need to convert this meter here into an ammeter, so I'm going to switch this for 10 amps, and I'm going to turn my dial all the way to 10 amps as well. So see how one of the prongs is now on the wire that used to be right here. So I took this black wire from my light bulb and I inserted my 2 prongs from the ammeter between the light bulb and the wire. So 307, and now my current is 0.22 amps. What is the resistance of the light bulb? We're going to use Ohm's law, which tells us that resistance is voltage over current. So it's going to be 307 divided by 0.22. Obeying the rules for significant figures, I will have to say that my resistance is 14 ohms because I can only give myself 2 sig figs due to the current. It's a division, so therefore I have to go by the least number of significant figures. All right, so that was one circuit, part 1. I took my circuit consisting of 1 light bulb, a battery, and a meter, and a switch, and I measured volts on the light bulb, figured out its resistance, 14 ohms. Now we're going to move on to part 2. This light bulb will be a part of my new circuit, so I will remember that it has resistance of 14 ohms. The rest, absolutely forget whatever else you got in part 1. All that matters is this. Resistance of your light bulb number 1 is 14. We need to add another light bulb. So this we discovered to be 14 ohms. Now it's connected in series, and I need to figure out my second light bulb. I'm only allowed to measure the voltage on the battery this time, right there, and the current. See how I'm saying that it's going to be the current in the second light bulb. Okay, you remember that the current through series is going to be equal. So if I'm telling you the current in light bulb number 2, I'm also giving you the current in light bulb number 1. So when I connected, my current now is less than what it was before, right? It should make sense. Before I only had 1 resistor, now I have 2 resistances add up. Greater the resistance, less current I will have. So instead of 0.22 before, now I have only 0.17. Okay, so that is my current through light bulb 1 or light bulb 2 for that matter. And then the voltage of the battery, when I connected my voltmeter to my battery, it was 3.83. Again, It doesn't matter what you had here. Forget it. It's a different circuit, even though it's the same battery. Less, if you remember internal resistance, smaller current times the internal resistance, your battery will need less voltage to itself. So therefore, more is left over for our light bulbs. Now that I know that my current in the new circuit is 0.17 amps, that is the current not only through light bulb 2, but also through light bulb 1. So moving on to the next page, the current in the first light bulb, 0.17, not 0.22. 0.22 was in the previous one. In this part, you have a new circuit and a new current. For both of them, it's 0.17 amps. And what is the voltage across the first light bulb? You remember that voltage is current times resistance. Current is 0.17 and resistance in part 1 for light bulb 1, you calculated it, you determined it experimentally, and it was 14. So you get 2.38 volts. I'm going to stretch my rules a little bit just for the sake of the exercise. What is the voltage across the second light bulb? I know that my total is 3.83, and then if I subtract 2.38 from it, I will get 1.45 volts. So then what is the resistance of the second light bulb? Again, we know that the current is 0.17A, then resistance is voltage over current, 1.45 divided by 0.17, and now I'm going to round it to 2 sig figs as it should be, and it's going to be 8.5 ohms. Boom. So this is part 1 and part 2, which concludes the part about circuits in series. If you need to practice more, have this video in front of you, follow through step by step until you are absolutely sure how to do this, and then we can take that. See you in class.